Artificial intelligence may seem like a futuristic buzzword, but its history stretches back more than half a century. It's a story of imagination, breakthroughs, setbacks, and the relentless pursuit of teaching machines how to think, or at least, how to simulate thinking. The journey begins long before computers, in ancient myths. In Greek mythology, Hephaestus, the god of blacksmiths, created intelligent, mechanical servants. In Jewish folklore, the golem, a clay creature brought to life, protected its creators. These stories reflect a timeless human fascination with animating intelligence. But AI, as a scientific concept, began to take shape in the 20th century. In the 1940s, British mathematician Alan Turing proposed a model of a theoretical machine, now called the Turing machine, that could perform any computation. In 1950, he published Computing Machinery and Intelligence, where he famously asked, "Can machines think?" This paper introduced the Turing test, a benchmark for determining if a machine could exhibit behavior indistinguishable from a human. The field officially launched in 1956 at a workshop at Dartmouth College. This gathering, organized by John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon, coined the term artificial intelligence. They believed that human intelligence could be precisely described and that machines could be made to simulate it. The early years were optimistic. Programs like Logic Theorist and General Problem Solver showed that computers could solve math problems and navigate puzzles. Researchers believed that full human-level intelligence might be achieved in a generation. But progress slowed. By the 1970s, AI hit its first major roadblock, known as the AI winter. Funding dried up as ambitious promises went unfulfilled. Computers were too slow, memory was limited, and common-sense reasoning remained elusive. Despite setbacks, some breakthroughs endured. The 1980s saw the rise of expert systems, rule-based programs like XCon that could perform specialized tasks, such as configuring computer systems. They were used in medicine, geology, and engineering. But these systems had limitations. They couldn't learn. Every rule had to be manually programmed. As complexity grew, so did maintenance costs. Eventually, expert systems declined, and AI faded again into the background. The 1990s marked a turning point. With more powerful computers and larger datasets, machine learning, especially neural networks, made a comeback. In 1997, IBM's Deep Blue defeated world chess champion Garry Kasparov, proving that brute force computing could match elite human intuition in structured games. Around the same time, speech recognition began to improve. Systems like Dragon Naturally Speaking paved the way for future voice assistants. But the real game changer came in the 2010s. The explosion of digital data and affordable computing power reignited interest in deep learning. In 2012, a neural network called AlexNet dominated the ImageNet competition, reducing image recognition error rates dramatically. This sparked the deep learning revolution. From there, AI accelerated rapidly. Google Translate got smarter. Siri and Alexa became household names. Self-driving car prototypes hit the roads. AI beat humans in video games, poker, and even art competitions. In 2016, DeepMind's AlphaGo defeated Lee Sedol, a world champion in the ancient board game Go, a feat many thought was a decade away. Unlike Deep Blue's brute force approach, AlphaGo used a blend of neural networks and reinforcement learning, showcasing strategic intuition. In the late 2010s, transformer models emerged. These models, like BERT, GPT, and T5, changed natural language processing. They could write essays, translate languages, summarize articles, and generate poetry. GPT-3, released in 2020, stunned the world with its fluency and coherence. AI began powering everything: movie recommendations, spam filters, personalized shopping, fraud detection, healthcare diagnostics, and beyond. But with power came responsibility and questions. Who owns the data? How do we prevent bias? What happens when machines create art or write code? Can AI be conscious? These questions define the current era. As we entered the 2020s, AI evolved from niche research to global infrastructure. OpenAI, DeepMind, Meta, Google, Amazon, Microsoft all invested billions into building smarter, faster, more capable systems. In 2022, OpenAI released ChatGPT, based on GPT 3.5, followed by GPT-4 in 2023. Suddenly, millions had access to conversational AI, not just as a novelty, but as a tool for work, learning, and creativity. Companies used AI to write reports, analyze legal documents, generate ad copy, and even design user interfaces. AI art generators like DALL-E and Midjourney sparked debates over creativity, ownership, and the role of human artists. And yet, the history of AI is far from over. We're just beginning to grapple with its implications: social, ethical, economic. Some see it as the dawn of a new industrial revolution. Others warn of existential risk. What's clear is this: AI is not a single invention. It's a tapestry woven from decades of ideas, experiments, failures, and breakthroughs. From Turing's theoretical machines to today's AI chatbots and image generators, the field has evolved dramatically, and it continues to accelerate. So where are we headed? Some researchers aim for artificial general intelligence, systems that can learn and reason across any domain, like humans. Others focus on narrow but powerful tools. Either way, the pace is relentless. But perhaps the most important question isn't what AI can do, it's what we choose to do with it. Because the history of AI isn't just about machines. It's about us, our hopes, our fears, our values. And as we write the next chapter, that story belongs to all of us. Let's take a step back and think globally. While much of AI history is rooted in the United States and the UK, other nations have played vital roles. In Japan, the fifth-generation computer systems project, launched in the 1980s, aimed to leapfrog computing capabilities through logic programming. Although it didn't achieve all of its goals, it inspired broader global collaboration and investment. In Canada, researchers like Geoffrey Hinton, often referred to as the godfather of deep learning, pioneered techniques like backpropagation and convolutional neural networks. His students went on to lead AI at Google, Facebook, and other major tech firms. Meanwhile, China rapidly emerged as an AI superpower. With access to vast amounts of data, a massive tech workforce, and government support, China has pushed AI forward in areas like facial recognition, autonomous delivery robots, and smart city infrastructure. the European Union focused heavily on AI regulation. Projects like Horizon 2020 aimed to fund ethical, transparent AI research. In 2021, the EU proposed the first comprehensive AI law, aiming to balance innovation with protection of rights and privacy. And in developing countries, AI has been leveraged for social good, optimizing irrigation systems in India, diagnosing malaria in Africa, and supporting crisis response with drones and predictive analytics. Each region shaped AI through its own priorities and challenges. Let's not forget pop culture's influence. From HAL 9000 in 2001, A Space Odyssey, to The Terminator, to Hearst. AI has often been portrayed as either a villain or a romantic enigma. These depictions reflect our collective anxieties and aspirations. They echo core questions. Can a machine feel, understand us, surpass us? Pop culture has also inspired real-world innovation. The communicators from Star Trek predated the flip phone. J.R.V. Ice from Iron Man isn't far off from today's smart assistants. The boundary between fiction and innovation keeps getting thinner. Education also transformed thanks to AI. Students now use adaptive learning platforms that tailor lessons to their pace and style. AI tutors provide real-time feedback, and language learning apps leverage neural networks to improve pronunciation, grammar, and fluency. In the job market, AI reshaped hiring. Resumes are scanned by algorithms. Video interviews are analyzed for tone and body language. Companies use AI to match candidates with roles before humans review them. But this comes with challenges. Bias in AI system, based on skewed training data, has led to discrimination in hiring, lending, and law enforcement. A facial recognition system might misidentify people with darker skin tones. A resume filter might favor male applicants. These aren't just technical flaws, they're societal ones, amplified by code. This sparked a rise in AI ethics. Institutions like the AI Now Institute, the Partnership on AI, and university labs emerged to study the intersection of AI and society. Experts now ask, not just, can we build this, but should we? One major shift in recent years is open access. Now we see preprints, open source code, and public models. Hugging Face, for example, became a central hub for transformer models and NLP tools, democratizing access to cutting-edge AI. This openness accelerates innovation and fosters global collaboration. To today, AI research moves incredibly fast. New papers are published daily. Breakthroughs come monthly. What seemed impossible 5 years ago is now commonplace. Yet the core questions remain the same. How do we ensure AI serves humanity? Who gets to decide what good AI looks like? And how do we build systems that reflect the diversity of the world, not just the biases of the few? The history of AI is a story of iteration, from myth to model, theory to application. Looking forward, it's a story we're still writing. And the next sentence starts now.